Hi guys, welcome to my channel. In today's class, we're going to be solving systems of linear equations using the Cramer's rule. Now, the Cramer's rule is a matrix method of solving systems of linear equations. So for today's video, we're going to be working on linear equations involving two variables. So that way, if we're working with two variables, if I'm changing it to a matrix form, it's going to give us a 2 by 2 matrix. I want us to have this in mind. A two variable equation gives us a 2 by 2 matrix. So now, before we move into solving a question, like bringing in a question for us to work with, let's take, for instance, we have this given equation. I'm going to be representing them in letters and then show us the method of solving with these letters. Then after that, we can integrate this method in solving actual linear equations. So let's take, for instance, we have a1x plus b1y equal to c1. And then I have a2x plus b2y equal to c2. So the letters A, B, C represent numbers. So where A and B are the coefficients of x and y. So the x and y are the unknown variables we are looking for in this equation. Now, the first thing I'm going to do here is that for we to use the Cramer's rule, remember we're working with the Cramer's rule. So for we to use the Cramer's rule, we have to first of all change this equation, more like write this equation into a matrix form. Now, for we to write this equation into a matrix form, I'm going to be working with the coefficients of x and y. Now, what are the coefficients of x and y here? We'll have them to be a1, b1, a2, b2. So the first thing I'm going to write are the coefficients of x and y. Now, let's have it. We'll have a1, a2, and then I have b1, b2. So this is the first matrix form. Then we'll bring in another matrix. So now we're going to write the coefficients we're looking for. We're looking for x and y. We're looking for the value of x and y, which is equal to the values of c1 and c2. It is equal to c1 and c2. So now I've been able to express this equation. I've been able to express this equation in a matrix form. Now this is what it looks like in a matrix form. Now after we've expressed the equation this way, the first thing we'll have to do is to look for the determinant of this part. We'll have to look for this determinant. So because this is a 2 by 2 matrix now, then after we get to the determinant of this place, we now have to look for the determinant of the coefficient of x separate and also the determinant of the coefficient of y separate. So now let us work with this one by one. So for the first one, we'll have this A1, B1, A2, B2. So let us call it D, which is determinant. D stands for determinant. So for me to look for the determinant of this matrix, I'll be having A1, A2, B1, B2. So in our last video, I discussed the determinants of a 2 by 2 matrix and a 3 by 3 matrix. You can do well to watch that so you get a detailed knowledge of how to find a determinant of a matrix. So now let's do this 2 by 2 matrix. So here we're going to be having the plus sign and here we'll have the minus. So for a 2 by 2 matrix, we have to multiply the diagonal. So meaning that A1 times B2, which is going to be equal to A1 B2. And then because of this minus sign, we'll have at this place. So it's going to be minus, then multiplying the diagonals, which is minus A2 B1. So now this is the determinant of this matrix. This is the determinant of A1 B1 A2 B2. So like I said, after we look for the determinant of this place, after we get this determinant, the next thing is to look for the determinant of the coefficient of x and the determinant of the coefficient of y. So let's work with the determinant of the coefficient of x. Now for me to look for the coefficient of x, if we go back to what the equation looked like, coming back to this place, we'll see that the coefficient of x is this. Like this is x, this is x. So the coefficient is what? A1 and what? A2. So meaning these are the coefficient of x. So what I mean is this, I am going to replace this coefficient of x with C1, C2. So meaning I'm going to remove this A1, A2 and replace it with what? C1, C2. Because I am working with the coefficient of x, that is how to get the determinant of the coefficient of x. So which I'm going to denote as dx. I'm going to denote it as dx because it's the determinant of the coefficient of x. So just like I said, we're going to replace A1 and A2 with what? C1 and C2. So now this is going to give us something like this. C1, C2, and then we'll have our coefficient of y, which is B1 and B2. We'll have it there, which is B1 and then B2. So take note, the only thing that was changed is what? A1, A2, which was replaced by what? C1, C2. So that's what we'll have here, C1, C2, and then B1, B2. So the next thing is to look for the determinant of this. So looking for the determinant of this, remember, we'll have to put our plus and the minus sign and then multiply the diagonals. So the dx becomes, this times this, which should give us C1, B2. Then because of this minus sign we'll have here, we'll have minus, the second diagonal is what? B1, C2. So now let's look for the determinant of y. So the determinant of the coefficient y is dy, which is going to be, now let's come back to the equation. So here we'll see that the coefficient of y here is what? B1, B2. The coefficient of y is B1, B2. So meaning that here we'll have our B1 and B2, we are going to replace it with what? C1, C2. So just like we did with the A1 and A2. So now we are working with the coefficient of y, which is what? B1, B2. So I'm going to remove B1, B2 and replace it with C1, C2. So now let's have it. Our A1 and A2 will remain the same because we are not working with the coefficient of x. So A1, A2. Now what is going to change is the B1 and B2, which we are changing towards C1 and C2. So we're going to replace the coefficient of y with C1, C2. Now working with the matrix, it's going to give us, the determinant of y is going to give us, so we'll have to do our plus and minus at the top, remember, plus, minus, and then multiplying the diagonals, this is A1, C2, because of this minus here, then we have minus the diagonals, A2, C1. So I want us to take note of what we've gotten now. We've gotten D as this, which is the normal determinant of the equation without switching the coefficients. And then we've got our determinant of x as this. And then we've got our determinant of y as this. So what we are trying to do in essence is that with the determinant of x and the normal determinant, we can get the value of x. And then with the determinant of y and the normal determinant, we can get the value of y. So with what I highlighted here, we can say that the value of x is going to be the determinant of x over the normal determinant. And then the value of y becomes the determinant of the coefficient of y over the normal determinant. So you know the value of dx. We know the value of dx. That's, if we're working with normal number, we're going to, these coefficients are representing numbers, like I mentioned earlier. So let's assume we'll have numbers there. It's going to be C1 times B2, which is going to give us a number, minus B1 and C2. When we multiply them, it's going to give us a number also. So the number minus that number will get a value. Now that value we got here, and then the value we got for D, if we divide them together, we get the value of x, and likewise the value of y. Now let's solve with an actual question. Now the question says, solve the following equation using CRAMER'S rule. Now find the value of x and y. So the first question there is, our A says 2x plus 3y equal to 12. And then we'll have x minus 5y equal to minus 7. So remember, the first thing we have to do is to write this in matrix form, which is going to give us, remember, you are going to be bringing out the coefficient of x and the coefficient of y. So the coefficient of x and y is what? In this place, we'll have 2. For this place, the coefficient of y is 3. Now here, the coefficient of x is 1, invisible 1. So we're going to write our 1. And then here, the coefficient of y is minus 5. So we'll have our minus 5, and then when I close this one, so what are we looking for? The unknowns we are looking for are x and y. So this equation is equal to, we'll have them to be 12 and minus 7. So this is what it looks like, writing them in matrix form. Now the next thing is to look for the normal determinant of this equation, which is what I said, this part. We're going to look for this determinant because this is a 2 by 2 matrix. So after we get this determinant, we're now going to look for the determinant of the coefficient of x and then the determinant of the coefficient of y. So to get this part, I'm going to label it D, which is what we used in our illustration earlier. So now let's bring out the matrix we're working with. So we have 2, 1, 3, and minus 5. So remember, to find a 2 by 2 matrix, the first thing we'll have to do is to have our plus and minus at the top. Now we'll multiply the diagonals. So multiplying the diagonals now, we'll have this should be equal to, we'll have 2 times minus 5. That's working with this one first. We'll have 2 times minus 5. Then we'll have this minus sign. So which we are going to call minus, and then the diagonals there is what? 3 times 1. So we'll have 3 times 1. Let's have it in brackets so we don't make a mistake. These two are together and these two are together. So now let's solve. Now we'll have D to be equal to 2 times minus 5 gives us minus 10. And then we'll have our minus 3 times 1 gives us 3. Now D is equal to minus 10 minus 3 is minus 13. Let's take note of this. Our D is equal to minus 13. Now let's look for the determinant of the coefficient of x and the determinant of the coefficient of y. So now we are looking for dx. We are looking for dx. So from what we did earlier from the illustration, we observed that if we are looking for the determinant of the coefficient of x, the value of x, which is this, becomes what? Replaced. We have to replace it with the value of c. So we have to replace the coefficient of x, which is 2 and 1. We have to replace with the value of c, which is 12 and minus 7. So now let's have it. We'll have 12 minus 7. Then the coefficient of y remains the same, which is 3 and minus 5. Now let's find the determinant. The determinant of the coefficient of x becomes, remember to have your plus and minus here, then you multiply the diagonals. So multiplying the diagonals, the first thing we'll have here is 12 times minus 5. We're going to write it 12 times minus 5. Then after that, we'll have this our minus here. We'll have minus here, which is going to be minus, and then I have the second diagonal, which is 3 times minus 7. So we'll have 3 times minus 7. Now let's multiply that. So 12 times minus 5 is minus 60. And then we have minus, and 3 times minus 7. 3 times minus 7 is minus 21. And let's not forget that minus times minus gives us what? Plus. So our d of x becomes minus 60 plus 21 will give us minus 39. Minus 39. So now that we've gotten the determinant of the coefficient of x, let's look for the determinant of the coefficient of what? Y. So now let's have it. Our matrix becomes, we're going to keep the coefficient of x, we're going to write it. So the coefficient of x from what we have here, the coefficient of x is what? 2 and 1. We're going to write it. So we'll have 2 and 1. So remember, we are working with a determinant. We're working with the determinant of what? We're working with the determinant of y. So we are working with the coefficient of y, meaning that the values of y will be replaced by c. What we have as our value of c, the values of y will be replaced by what we have as the value of c, which is going to be 12 and minus 7. 12 and minus 7. So the next thing we'll have to do now is to find the determinant of the coefficient of y. So which is dy is equals to, now remember the first thing we'll have to do is to do plus and minus. So remember, we have to multiply the diagonals first. So we'll have 2 times minus 7, and then remember this minus sign we'll have here, so which is going to be minus, and then the next diagonal is 12 times 1. So we'll have 12 times 1. So multiplying this, we'll have 2 times minus 7 is minus 14, and then we'll have minus 12 times 1 is what? 12. So working on this, minus 14 minus 12 gives us minus 26. So this way we've been able to get the determinant of the coefficient of x, we've gotten the determinant of the coefficient of y, and we've also gotten the normal determinant. So the normal determinant is what? Minus 13. So remember that the formula for getting x is equal to dx over d, and then the formula for getting y is dy over d. So therefore, x is equal to dx over d. Now, what is the value for determinant of the coefficient of x? Is minus 39 over the value for the normal determinant is minus 13. So when I divide this, minus 39 divided by minus 13 gives us 3, gives us the value of 3. So x is equal to 3. Now for y is the determinant of the coefficient of y over d. So the determinant of the coefficient of y will have minus 26 all over, the normal determinant is minus 13. So when I divide minus 26 over minus 13, I'll be having 2. So therefore, we've been able to get the value of x as 3 and the value of y as 2. So this is the answer for question number 1. Now let's look at what question number 2 asks us to do. So for question number 2, we have, that's the B part. The B part says x minus 2y equal to 4, and then minus 3x plus 5y equals to minus 7. So now let's proceed to solve this question. So the first thing we have to do is to write this in matrix form. So writing this in matrix form, I have the coefficient of x, and the first value is what? There's an invisible one here. Let's not forget. So we have 1, and the coefficient of y is minus 2. The coefficient of x under is minus 3. The coefficient of y is 5. So the unknown variables we are looking for is x and y. And then our value or equation is equal to 4 and minus 7. So remember, the first thing is to look for the normal determinant, which is this 2 by 2 matrix we have here. This is the 2 by 2 matrix. So D is equal to, let's have the matrix back, 1, minus 3, minus 2, and 5. So looking for this determinant, we are going to be having, remember to change to add the signs plus and minus. Now multiplying the diagonals, the first one we'll have here is what? 1 and 5. So this is going to be 1 times 5. Remember this minus sign here. So let's have it minus, and then we'll have minus 2 times minus 3. So this is going to give us 1 times 5 is 5, minus, then minus 2 times minus 3. Minus 2 times minus 3 is going to give us a positive 6. Now we are left with 5 minus 6, which is equal to minus 1. So our normal determinant is equal to minus 1. Now let's look for the determinant of the coefficient of x, which is d of x. Now this is going to be equal to, now let's write the matrix. So remember that we are going to replace the coefficient of x. So we are going to replace the coefficient of x with the values of c. The coefficient of x here is 1 and minus 3. We are going to replace it with 4 and minus 7. So we'll have 4 and then minus 7. And then for the values of y, we are going to write it as it is. That's for this second part. You know, we are working with the determinant of x. So now we are going to now have our values of y remaining minus 2 and then 5. So now let's solve this. So looking for the 2 by 2 matrix, please do not forget to add your plus and minus. Now let's multiply the diagonals. So d of x is equal to, so we'll have 4 times 5 here, which is going to give us 4 times 5. Remember the minus at the top. Then we have the second diagonal to be minus 2 times minus 7. minus 2 times minus 7. Now this is going to be 4 times 5 is 20 minus, so minus 2 minus 7 is going to give us a positive 14. Now we have 20 minus 14. Our determinant of the coefficient of x is equal to 6. Now let's move to the determinant of the coefficient of y. So having our matrix, so because we are looking for the coefficient of y, the values of x remains the same, which is 1 and minus 3. Then we're going to replace the coefficient of y, which is this. We're going to replace it with what we have here, which is 4 and minus 7. So it is replaced by the value of c, which is 4 and minus 7. Now let's solve this question. We have dy equals to, remember to add your plus and minus. So the first diagonal is 1 times minus 7. Then we have minus, which is this minus here. So the second diagonal is 4 times minus 3. Now we have our dy to be equal to 1 times minus 7. 1 times minus 7 is minus 7. Then we have minus 4 times minus 3 is minus 12. So remember, minus times minus gives us plus. Now we have minus 7 plus 12. So the determinant of the coefficient of y gives us 5. Now we've gotten our value of the normal determinant to be minus 1. We got the determinant of the coefficient of x to be 6. We got the determinant of the coefficient of y to be 5. Now let's find the value of x and y. So therefore, x is equal to the determinant of x over the normal determinant, which is, the determinant of x is 6 over the normal determinant is minus 1. So 6 divided by minus 1 gives us minus 6. So for y, we'll have our determinant of y over the normal determinant. So the determinant of y there, we got 5 and normal determinant is minus 1. So it's going to be 5 over minus 1. So 5 divided by minus 1 gives us minus 5. So therefore, we can say that the value of x is equal to minus 6 and the value of y is equal to minus 5. So that's our answer. So I believe with these two questions we've solved and the first illustration that was given, we've been able to understand how to solve system of linear equation involving two variables. And like I said, the two variables will lead you to a 2 by 2 matrix. So let's have this question. I would love you to just do it during your leisure time. Like after learning this, you can just practice so you know if you properly understand this concept. So, and then after you solve it, you can drop your answer at the comment section. I will definitely go through it, and if there is any need for correction, I will actually give you feedback on your answers that you provide. So this is our first question I would love us to try, and then for the second question, we'll have our 2x plus y equal to minus 1, and then we'll have our x minus 2y equal to 8. So like I said, once you solve this, drop your answer at the comment section. I will definitely give you feedback. So thank you very much for joining me to this point. Yeah, if you're with me to this point, thank you so much for supporting my channel, and do well to please like, and if you've not subscribed, please subscribe. Subscribe and turn on the notification bell so you'll be informed and notified when I drop my next video. Thank you very much for joining me in today's class. See you in my next class. Bye.